Greetings, my wonderful chemistry students. We're going to talk about Lewis symbols for just a minute. Lewis symbols are a way of representing an atom, could also be an ion, with its valence electrons. Let me start just simply by showing you what a Lewis symbol is. Let's talk about carbon. So students, to be able to do Lewis symbols, what you need to know is the number of valence electrons. And so carbon has, let's say, 4 valence electrons. There's a few different ways of getting to that. I suppose the more formal way is to look at it through the lens of its electron configuration, which is 1s2, 2s2, 2p2. Remember, valence electrons that occupy the highest energy level, which would be the second main energy level for carbon, which means that these two and these two electrons both occupy on the second main energy level, which means they're your valence, so a total of 4 valence electrons. So that's one way to bite that, but there's a much easier method. If we go to our periodic table, so here's a pretty awesome periodic table. One way to count your valence electrons is by counting in the S block and P block if you need to. But what we're going to do is we're going to count the total number of atoms that are in the S or P block from the left of that atom. Carbon, of course, counting from the left would be starting again at lithium, beryllium, boron, carbon. That's 4 elements. It's 4 steps. What about someone like bismuth? Remember, you just count on the S and P block. So going all the way over to cesium, that's 1, 2, and then over to thallium, 3, 4, 5. Bismuth has 5 valence electrons. So now that we can determine quickly the number of valence electrons that any given element has, to do a Lewis symbol is very, very, very simple. What we're going to do is write the symbol for the atom, and then we're going to use dots to represent valence electrons. So I want you to imagine a hypothetical world of 4 spots around my carbon. So I'm going to place my first valence electron. It doesn't matter where you place your first valence electron. It's irrelevant. I'm now going to place my second valence electron, and then my third, and then my fourth. So this is the way the Lewis symbol for carbon would look. Why do we place the dots or the valence electrons around carbon in the way that we do? For instance, it is actually incorrect to say that this would be carbon's Lewis symbol. That's wrong. Equally, this is wrong as well. So it would also be incorrect to say that this would be carbon's structure, any other variation of that. Again, this is the only one that's good to go. So why do we place electrons this way? Well, it kind of goes back to Hund's rule. If you remember how we fill in electrons, 1, where does the next electron go? Well, it goes there in that available orientation. And the same thing there for this electron as well. We don't, in fact, double up another electron until 1 electron in every single orientation. So same idea goes for these as well. These electrons are going to orientate themselves to the extent that they are of lowest energy or as far apart as they can. And so that's why we're going to draw that Lewis symbol that way. Let's do nitrogen. Remember that nitrogen has 5 valence electrons. So 5 dots get to go on the nitrogen. So 1, and again 2, 3, 4. So where does the 5th go? Well, this is where we finally get to come in and actually double up now. Let's try someone like fluorine. Fluorine has, again, 7 valence electrons. Feel free to pause this video and go work that out yourself. See if you can figure out why fluorine has 7 valence electrons. Let's do it. So we're going to write F, and here we go. Start dotting. This time I'll start over here on the left. So 1, 2, 3, 4. Okay, now we got a doubles. 5, 6, 7. So these are Lewis symbols. Let's say that we had to draw the Lewis symbol for an ion. Again, we base it off of the total number of electrons or valence electrons present. So, for instance, why don't we do the sulfur 2- ion? So we know that sulfur has usually 6 valence electrons, right? So sulfur, let's draw that out. So that's 1, 2, 3, 4, 5, and 6. But what exactly does it mean that this guy has a 2 minus charge. Well, it means that 2 additional electrons have been added. So where do we add those 2 electrons? I'll do them in blue. They'll go right, so 1 and 2. Now this is an ion, it has a charge. And so what we're going to do now is enclose it in brackets, square brackets, and then we're going to put the charge on the outside. So if you're doing a Lewis symbol for an ion, enclose it in brackets, and then of course put the charge in the upper right corner. Let's try one more. What if we had someone like calcium 2+? Well, what does calcium normally look like, right? So calcium normally looks like this, a 1, and we would technically put the 2 over there just to get it as far apart as we can. Remember, electrons want to repel. So, but what does it mean, going back, what does it mean that this guy has a 2+ charge? Well, it means that we've lost 2 electrons. And which electrons have we lost? Well, I bet you can guess the 2 that are there, right? So those bad boys have to go away. And so calcium's would simply be this. Obviously it's an ion, so we need to enclose it in brackets just as we did before. Nothing new or nothing special there. So we'll enclose in brackets. And again, we'll write the charge in the upper right corner. So that would be calcium's calcium ion's Lewis symbol.